fell 125.
All right. Lesson 1 of Unit 4. So we did the Wile E. Coyote problem yesterday. Now we're going to do, and it's just a more mathematical version of this. It's more straight mathematics. So we got the Steamboat Geyser in Yellowstone Park. It's capable of shooting from the ground at 48 meters per second. How high did the water shoot? 48 meters per second is like 120 miles per hour. It's pretty fast. So the question is, how high did the geyser shoot? Alright, so when we start a problem, we do it just like we do every other problem. We get a picture, we get an idea of what's happening, we do our knowns and unknowns, and then we try to solve the problem. Gives our brain a chance to think about it. And again, this is the pattern we've been following all along. So, sometimes it helps to start with that picture. Anybody ever seen this, by the way? Anybody ever seen this? No. Hey, fun fact of the day, did you know that Yellowstone is home of one of the world's largest known dormant volcanoes? Now, dormant means that it someday is going to come back to life and blow up the Midwest. So, just fun fact for the day.
Woo!
If it's so big that if it actually went when it goes because it's dormant, so it's when it's going to go. When it actually goes, it's going to change the entire landscape of the Midwest. So, give or take a couple, 10, 20,000 years, and in that time range, it should go probably more like 50,000 or 100,000 years. So anyway, something, if you wanted something to worry about tonight, there you go. Fun fact of the day. All right, so the water launches up like that. We'll call going up as positive, down as negative. So it's going to go up this way. Now, we're going to draw a V versus T graph of this. Does it start off with a big speed or slow speed? Big speed. We're going to look at it not while it's in the ground, but after it shoots out of the ground. So we're going to start with a big speed like this. And as the water goes up, what happens to its speed? It goes down. It approaches zero. Like so. Okay? Now let's look at some different things that we can find from this. Again, I haven't tried to start solving this problem yet. Yellowstone Park is capable of shooting the hot water up from the ground at 48 meters per second. So is that an initial or final velocity? Okay, so what's our final velocity going to be at the highest point? Zero. So is that initial or final? Initial, because it's at the ground level it's shooting up. So we got VI equal to 48 meters per second. I'll go ahead and just put our usual list of usual suspects down here. Now again, I use delta Y this time because it's vertical. Okay. So we want to follow this water until it's up here. When it's up here, what's its speed? Zero. When I throw this tape up in the air, for example, I launch it out of my hand somewhere up here. Well, that didn't work. At the highest point there, what was the speed at that instant? Zero. Now, how long did it stay zero? For an infinitesimally small amount of time, but for that infinitesimally small amount of time, it was zero. Because if you narrow it down, it's only there for an instant. That's what an instant means. Anyway. All right, so yeah, so we got 48. So we're our velocity is zero. Now this one was implied. You had to think through that one. That's the ones we don't like. You had to think through. You had to draw the picture. You had to know what I'm saying? That one's the harder part to teach, is how to get students to, when they're not in the problem, how to find out a variable. Sorry, but that's where, you know, you got to go to the next level. Now acceleration, do no acceleration. Yeah, well, you don't know. So it's this slope here. We'll come back to that. And t we don't know. We definitely don't know anything about time. Delta y, this is what we're trying to find right here, is how high it goes. Up there like that. That's what we're trying to find. So let's look back a couple of slides. All right, somebody read that first sentence up there.
From yesterday's lab, we determined that the acceleration due to gravity is negative 10 meters per second squared.
Now, for what objects are those for?
Without air, pressure.
So it's just, is it just feathers?
No, it's for every object.
Oh, it's for every object. So that's what we learned about yesterday. For every object, without air resistance, it's negative 10 meters per second squared. Now, I know there's air, and it's not going to be the most accurate way of looking at this, but for all our problems, we're just going to say there's no air resistance for now. We're going to keep the physics a little bit simpler for now. When we take into account air resistance, the physics gets a whole lot more difficult. So we'll just do it without air resistance until we get to that point. To get you in the habit. All right, so back to this problem. So what's our acceleration? Negative 10 meters per second squared. Unless you change planets, that's the way it is for every single one of these problems. All right, so that's a given. It's a guarantee every time. Okay, so we now need to find an equation that uses delta V, VF, A, and delta Y. All right, so we need to use our equation list from previous years. Now, for some reason you lost that list. I know there's a lot of reasons right now that you could have lost it. I'll print one off for you right after I'm done with this lecture, and I'll give you that list again. You don't have, if something, the tornado agent won't work, or something like that. Yeah.
Maybe the equation 4 is VF squared equals V initial squared plus 2 delta x times acceleration.
Yep, you got it. And I changed it to delta y instead of delta x there since it's vertical. If you want to leave it as delta x, it's not that big a deal to me. It's so yeah, let's go ahead and solve this. So we got 0 squared is equal to 48 squared plus 2 times negative 10 times delta y. Now I don't know what 48 squared is, so I'm going to calculate that one out. So you get 2,340 minus 20y. So we get this over to this side, so that's 20y is equal to 2,304. We divide both sides by 20. Delta y is equal to 115 meters high. That's high. It's well over a football field high. All right, so there you go. All right, any questions on that? All right, on the worksheet number 1, I think there's one Wile E. Coyote problem. And then there's several problems like this. I think we're going to do 2 worksheets like this, that just to kind of get you back in that habit. And then there's really no new content until we're done. I think we got 2 worksheets and then a quiz. So quiz later this week or early next week. So then we'll start on Einstein's theory of relativity.